Here's a problem. Chemical engineer prepares mixture consisting of 5.5 grams of helium, 15 grams of neon, 35 grams of krypton in a piston cylinder assembly at STP. So this tells us the temperature and the pressure. You may not have this slide. Okay? So, take pen in hand and write this down. Okay? Calculate the partial pressure of each gas. So what we have is the masses of each gas. We can figure out the atomic masses so we can get the number of moles, and then we can go from the number of moles to the partial pressures. And with three components, we can add up the three partial pressures, and they'll have to add up to 1 atmosphere. Right? Okay, so here's what I'm planning to do here. I can find the molar mass of helium in the periodic table. I can do the same thing with neon. I can do the same thing for krypton. Helium's 4 grams, neon's 20.2, and krypton's about 84. So my plan is going to be as follows. I'm going to take the mass of each gas, and I'm going to go to the moles of each gas, and then I'm going to calculate the mole fraction of each gas. Capital Chi here, and then I'm going to use that to get the P1, P2, P3, the partial pressures, okay? But the first thing I need to do is get the number of moles. So first of all, I've got 5.50 grams of helium times 1 mole of helium over 4 grams. And that gave me 1.38 moles of helium to 3 significant figures. I actually used higher significant figures with this molar mass here. Then I did the same thing for neon. I have 15.0 grams of neon times 1 mole of neon over 20.2 or 20.2 is good enough grams of neon. And that sent me over to, looks like 0.743 moles of neon. And I did the same thing for krypton, 35 grams. 1 mole of krypton per 83.8 grams of krypton. And that gave me 0.420 moles of krypton. And the sum of the 3 moles to 3 significant figures was 2.54 moles of gas. 2.54. Now, if we want the partial pressure of helium, we can take the 1.38 moles of helium and the total number of moles and get the mole fraction, multiply that by the total pressure, which at STP is 1 atmosphere, and I can get the partial pressure of helium. Is everybody, let me just write it down and then I'll give you a chance to ask questions. Partial pressure of helium is equal to chi of helium times P total. Okay? And that's equal to 1.3, for some reason I have it written down as 1.375 here, don't know why, divided by 2.54 times 1 atmosphere, and that gave me 0.541 atmospheres of helium. Okay, So this is chi, the mole fraction, this many moles of helium over the total number of moles, and I'm multiplying it by P total, which is 1 atmosphere. Questions? Make sense? All right. Let's do the same thing for neon. P of neon is equal to chi of neon times P total. And that will be 0.743 moles of neon divided by 2.54 total moles times 1 atmosphere. And what did I get here? 0.293 atmospheres of neon. Okay? And one more step. P of krypton is equal to chi of krypton times P total. And that's equal to 0.420 divided by 2.54 times 1 atmosphere. And that gave me 0.16, sorry, 165 atmospheres of krypton. Now, if I did this right, what should these three values add up to? P total, 1 atmosphere. And I think it's what? 0.999 atmospheres. That's pretty close for